So we actually have a customer implementation here where they have 2 data centers, and so we can actually show you the migration. So what we usually have when you go into this view is, we call it the My Storage view. It basically gives you the system state, and so you have this pictogram that basically shows you the overall activity on the front end, and then our status of copying data into the cloud. So you can actually see, to what point in time the cloud has protected you, and how much of your data in terms of time is actually living in the middle tier, and also the numbers of data centers. And so what we have here for this demo is 2 data centers in the Boston area. And all synchronously replicating to our point of presence in downtown Boston. And so we actually also show a map. One of the great things about what we do is that all the known data center locations are out there, so we're able to draw maps and give you really interesting link statuses and things like that. So if you actually wanted to move a workload from one place to another, you can just simply click on the map. And you can actually move right from the map. So you click on the data center, and you can actually see which workloads are sitting in each data center. You can select one of the workloads. So we're going to just pick one to torture right now, and we'll just go ahead and move it to the other data center. So you just select a destination. You also select who's going to access it at the new location. And we actually already have this. We'll show a little bit later on how we get all the access control information, but we basically just start the move operation. There isn't an actual move operation. All we're really doing is we're surfacing the LUN in the other side. So it's just like Howard mentioned before. Logically, we're a single array. It's just that this is showing up on a different port. So when you click yes, so first of all, one of the things that we're doing is we're shutting off. We're doing a cruel and unusual act because we're pulling out a LUN from a running server in this particular case. So we want to actually tell you that we're going to set it offline. But all you do is click yes, and then if you go back, you'll actually see the LUN has moved to the other side. So this is disaster recovery orchestration for us. Yep.
That was it.
Yep.
What else do you want to show?
Yep.
Talking all day.
Okay.
Want to continue?
Oh, yeah, let's continue.
Okay.
There's a few of us who are interested in the data sovereignty aspect of things as well. So if we could get to that, that would be really cool.
And did you want to answer his question about multiple point-in-time copies?
Oh,
to restore
sure. Actually,
snapshots?
Yes, actually, why don't you do that? That's.
Okay. I figured to answer the second part of his question.
Oh, yeah, that's right. So it's right there.
We're running short on time, so feel free.
It's like
I can follow up with you guys separately on that.
Okay.
That's fine.
All right.
Okay, so let's move on.
I
think let's go back to the presentation. Let's see if we can.
Because the security data sovereignty thing is kind of important.
Actually, I think that's the next slide. So
I believe so. Security is the next slide, actually.
Security is very important.
Yes.
Yeah.
Right. So what do we do for security? So I mentioned before, the edge cache actually has each controller has a TPM module. TPM module is used to do key management. We're basically doing a S256 encryption at rest and in transit. We're doing it at wire speed, so we have a ton of compute there, and it doesn't affect your performance. And we also do a number of other, some might say, paranoid or annoying things for security, but we need to do them. So multi-factor authentication for user logins, even in the management console, is required for us. So you log in, we email you, then you log in again. So this is the standard operating procedure for us. The data centers themselves are also we're doing the upper tier of data centers. So we announced a relationship with Digital Realty. So these are very, very secure buildings. We had a party there last night and they wouldn't let us in. It's great. We just stayed in the lobby. And this is felt kind of weird. The security building, the security officers are behind us, staring at us behind a glass. But they're very secure buildings. They have man traps, basically fingerprint recognition, all sorts of checks there to make sure that you can't get physical access to any of our infrastructure. Our own operations team has to have periodic background checks, including financial background checks, so that we can assuage the fears of some of the customers. We have customers that are financials, and so this is what they do for their employees, and so therefore we must do them for ours. And we've also basically broken out the production network from the development network in such a way so that most of our development staff can't access the running service. So we have a parallel environment for them. And then we periodically pay people to try and break in, because you never know. And so we actually have an attestation from GuidePoint Security that did the first pen test. They just completed it this week. And we'll continuously do that. So anyone who's considering buying our service is able to look at the report. Any other questions on security? There are a couple of other things. We do use TLS, again, with keys that are managed via TPMs. So there are actually TPMs even in the point of presence. Really interesting scenarios are we've thought through all sorts of really interesting things. We actually are worried that someone's going to steal the edge off of the customer's premises. So if they do that, it effectively gets disabled. They'll never be able to connect it to the network. We also fix it so that we manage the configurations of those things. If you try and stick a foreign piece of hardware in there, we'll figure it out. We'll also shut it down. The connection to the cloud is also secure, and all the data actually lives in our VPC in the backend cloud. So our first implementation is with Amazon, but it is cordoned off, and obviously the data is encrypted there, but it's also inaccessible to anyone but us. So a little bit about timing. Why is this possible? I think we touched on some of these things, and so just to reiterate, one of the things that we do check for these days is that enterprises are actually interested in receiving primary storage as a service. Services are something that hasn't always been in vogue, but lately there's been a lot less objection to this. We're very, very connectivity leveraged in this company, and we couldn't do this 5 or 6 or maybe 10 years ago because Ethernet has not been always available in the abundance that we have right now. So we're able to get some really amazing pricing for high-speed connectivity. Object clouds are a solved problem, and so we don't actually have to build one of those. There are a lot of companies out there that try to do that. Obviously we're just leveraging the cloud rather than being a cloud. And then all of you are probably familiar with typical storage technology, but a lot of the deduping and caching and optimization technologies are more or less in the mainstream now, and so we're able to leverage those. They were pretty exotic, in years past. So all these things together are sort of the sets of reasons why something like this can be built now, and up until now it's been kind of difficult. One of these things is always missing, either the market or the back end or the connectivity. So talk a little bit about our heat map tool. Everyone knows that workloads are tiered. We actually, as part of the research for building this product, we actually went to a number of customers and collected very, very detailed SCSI trace data from running VM workloads. And this is sort of the functional basis of how we designed the system. We went through a very, very large number. I think I'm going to show you one example, a very large number of VMs, a whole bunch of very, very active workloads. And what we wanted to see is how could we cache and tier this data and still provide a level of performance that would be enterprise class. And so why don't we just go in and take a look at this. This is one of the customers. So basically what we did here is just laid out all the unique LBAs across all of their LUNs and how frequently they were touched over the course of a week. So this is an interesting graph because what it tells you, and so pretty much everyone knows about the big spike on the left. I think tiering is nothing new to people. That big spike on the left basically says that 90% of your IOs can be serviced from about 10% of your physical disk space. But what's really interesting is that bump in that middle tier, and that's really why we chose to do a metro approach to this. What we really wanted to do is to find a way to keep that second box there close enough to you so that you can actually get fundamentally all of your IOs serviced from someplace that's very, very close by. And so this is really one of the key technological differences between what we're doing and other types of cloud caching technologies. The value of the network is really that middle box.